oops, I should have put A after the word matrix. A square matrix A is invertible if and only if. IFF is a common shorthand notation for if and only if, so I just thought I'd throw that out there so you'll know it for the future. If the determinant of A is what? Not 0. Yeah. Okay, and what's the determinant of any identity matrix? 1. Yeah. Because there was a theorem, if a matrix is triangular, its determinant is the product of the elements on its diagonal. So in that case, it would be 1 times 1 times 1 times 1. And what does that A mean in vertical bars? Determinant of A. So we're going to learn how to compute determinants of square matrices and investigate properties of determinants. So remember that we know how to calculate the determinant of a 2 by 2 matrix, right? So the determinant of A, B, C, D, or alternatively notated in the vertical bars, which just means the determinant of A, B, C, D. How do we calculate the determinant of a 2 by 2? Very close. It's not the 1 over part, just the denominator part. Because, so the 1 over part is part of the formula for finding the inverse. So the thing that can't be 0 is the denominator of that fraction in the beginning. So the determinant is AD minus BC. So that fits with the theorem about the determinant can't be 0 or the matrix is not invertible. Because then you would be dividing by this quantity that is 0. All right, so we can find the determinant of a 2 by 2, and that's pretty easy, straightforward. And we're going to use that when we're trying to find the determinant of any larger square matrix. So the first method that we're going to learn is called a cofactor expansion. So we'll do a couple together, and again, this is just like a kind of a rote, learn the process kind of deal. So we're going to do a cofactor expansion across the first row. So the way it works, identify the first row, right? And then you're going to go element by element across the first row, and that's going to be a coefficient on a new matrix. So we're going to start with the 1 times. And what you're going to do, once you take the 1, you cross out the row and the column that 1 is in, and you take the determinant of the remaining matrix. So 1, 1, 4, 2. Now your signs alternate. So I started with a 1, a positive 1. Now I'm going to take the opposite of the next element in the first row. So I'm going to do minus 3. And then I'm going to put in what remains if I cross out the row and column that 3 lives in. So cross out the row, cross out the column. The remaining 2 by 2 matrix is 2, 1, 3, 2. So I did positive, negative, positive. Next element of the first row is the 5. When you cross out the row and column that 5 lives in, the remaining 2 by 2 is 2, 1, 3, 4. And that's our cofactor expansion across the first row. Now I just have 3 2 by 2 matrices, which I can use my formula AD minus BC to calculate those determinants. Okay, so AD minus BC, so it would be 1 times 2 minus 1 times 4 minus 3 times 2 times 2 minus 3 times 1 plus 5 times 2 times 4 minus 3 times 1. 2 minus 4 is negative 2. 4 minus 3 is 1. Plus 5 times 8 minus 3 is 5. So it's negative 2 minus 3 plus 25 is 20. Yeah, it's just part of the formula that you You alternate signs. Yeah. So here's the wrinkle. You do always alternate signs, but if you use an odd row or column to expand across, so we were doing a cofactor expansion across the first row, first being an odd number, right? So if you start in the first or third or fifth row or column, you start with a positive. And if you are starting on an even numbered row or column, you start with a negative and then alternate. So we're going to do this whole problem again. We're going to find the determinant again for the same matrix, but we're going to do a cofactor expansion down the second column. And because it's the second column and 2 is even, we start with a negative. So we know the answer should come out to 20, because the determinant of this matrix is 20. So it should come out the same. So I'm using the second column this time. Because 2 is even, we start with a negative as you expand down the second column. So instead of a 3, we put the opposite of 3. And then the matrix that remains, if you cross out the column and row that 3 is in, is 2, 1, 3, 2. Then switch to a positive. 1. Cross out the row and the column, and you have 1, 5, 3, 2. Switch to a minus. Oops. Minus 4. Cross out that row and column, and you have 1, 5, 2, 1. And now we calculate the 2 by 2 determinants. So I've got negative 3 times 2 times 2 minus 3 times 1, plus 1 times 1 times 2 minus 5 times 3, minus, I'm out of room, minus 4 times 1 times 1 minus 5 times 2. So that's negative 3 times 1 plus 1 times 2 minus 15 is negative 13 minus 4 times 1 minus 10 is negative 9. So I have negative 3 minus 13 is negative 16, and then negative 4 times negative 9. So this is negative 3 minus 13 plus 36, which is 20. So it comes out the same no matter which row or column you choose to expand across or down, but you have to remember the little sign rule, right? If you're using an even numbered row or column, you have to start with the opposite of the actual number. And if you're doing an odd numbered row or column, you start with the just the number. All right, so now I've got a 4 by 4, and I can use a cofactor expansion of my choice, which means you can choose any row or column you want. Which one do you want to use? The fourth column, right? Because it has a lot of zeros in it. And 0 times something is just 0, so it's going to save us a ton of work. So we're going to go down the fourth column. So you start with the 0, and the 4, because of the fourth column, 4 is even, you start with the opposite of the first number. So I'm going to put minus 0, even though minus 0 is still 0, just to remind us of the rule. I'm writing it down. All right, and then I'm going to write down the matrix that results when I cross out the row and column that 0 lives in. 4, 1, 3, oh, who cares, right? Because I'm just going to multiply it by 0. So who cares what's in there? Okay. So then I go to my next element from the fourth column, and I'm going to do a positive. I started with a negative. I go positive 2. This one matters. I need to actually fill out what's in this matrix. Cross out the row and column that 2 is in, and I have negative 1, 0, 2, 0, 1, 0, and 0, 2, 2. Next element from that row, from that column, is a 0. Again, I'm alternating the signs. And then I don't even actually care what's in there because I'm just going to multiply it times a 0. Whatever, I don't care. So these three pieces can all just drop away because they just are multiplying times 0. So I just have to work on this 2 times the determinant of a 3 by 3. So to find the determinant of a 3 by 3, we're going to have to do a cofactor expansion. Which row or column would you like to use? The first column. Yes. Yes, you could. That's from 3.2, which is the next section. But yeah, you could definitely easily turn that into a triangular matrix and then multiply. Yeah, but I'll present that in the next lecture. Although you all should know that because you read 3.2, right? Yes. So yeah, so we could use the first column or the second row. Both of them have 2 zeros in them. It doesn't really matter. So I'm going to write my 2 here. And then I'm going to put a big bracket to remind me, like I'm doing a bunch of work on here, then I have to multiply by the 2. So let's see, I'll do a cofactor. Let's do the second row because I like the positive one. So I'm going to have second row, 2 is even, so I start with a minus. 0 times, doesn't matter, plus 1 times, if I cross that out, I get negative 1, 2, 0, 2, minus 0 times something, doesn't matter, doesn't matter. So now I have my 2, and then I have 1 times AD minus BC, negative 1 times 2 minus 2 times 0. So I have 2 times, that's negative 2 minus 0, negative 2. So I get negative 4 is my determinant. So my question now, is the matrix that we just found the determinant of, is it invertible? Yes, as long as the determinant is non-zero, that matrix has an inverse. Questions? So this is very formulaic. Oh, sorry, go ahead. Yeah, for the signs, at first you said if it's odd, start with positive, then you start with the actual number. Yeah, yeah. So I should have been saying like the number and its opposite instead of positive and negative. Because if the number in the matrix, like let's just say, here's my matrix. And then, I don't know, whatever. If I'm going down the first column here, then I would do start with the negative 3, which is the actual value, right? And then it should be the opposite. So then it would be minus 1, and then it would be plus 2. That makes sense. So the signs here didn't alternate because this negative 3, think of that as the positive negative 3, right? And then you have minus 1, so that's the minus I introduced. And then you have the positive 2. Let me see if I can make this a little clearer. What if they are all negative? Negative 1, negative 2, negative 3. So if I'm going down the second row here, because this is the second row, it's even, you start with the opposite of the first number. So you would do 1 times the matrix, the determinant of the remaining matrix. And then that was the opposite. So then my next one would be the actual value, minus 2. And then the last one would be the opposite, positive 3. So in that case, they actually did alternate because they were all negative. Does it make sense? Okay, good. All right, so that's it. You're going to do some practice with finding determinants. Plus, there's some stuff in here about some theorems that you're going to discover about determinants.